Hello students, a very happy morning to all of you. Welcome to Science Online Learning. Today we are going to start a new chapter in science. Before that, let's quickly revise what we have already learned in our previous sessions. In our previous chemistry classes, we learned that chemistry is the branch of science that deals with the study of substances and their transformation. So we learned in detail about substances and transformation. So do you remember what is transformation? Transformations means a kind of change. So there are two kinds of change that happen around us every moment, and they are physical and chemical change. We also learned how chemistry evolved from alchemy to modern chemistry and the contributions of the founding fathers of modern chemistry like Robert Boyle, Antoine Lavoisier, John Dalton, and Mendeleev. And students, you may remember that Mendeleev gave the periodic table of elements, and John Dalton was the one who laid the foundation of modern science by giving us atomic theory in the year 1803. And Lavoisier disproved the four element theory, and Robert Boyle gave the Boyle's law and the law of partial pressures. So these are some of the important contribution of our founding fathers of chemistry. Next, in chapter 2, we studied about the role of chemistry in our lives, how chemistry is involved in each and every aspect of our lives, and how chemistry helps us in many different ways. We studied how chemistry is helpful in producing more crops and how chemistry is useful in the food industry, in food processing, and how lots of chemicals are used in preparing medicines, cosmetics, soaps, and detergents. And lastly, we discussed about the major role of chemistry in clothing or textile industry. In today's class, we are going to learn chapter 3 in chemistry, and the name of the chapter is Elements, Compounds and Mixtures. This lesson is another interesting lesson where you can learn what matter is made up of. Students, are you all ready to learn more about elements, compounds and mixtures? Yes, let's get started. Students, you all very well know that matter exists in three states. They are solid, liquid and gaseous state, and in this chapter you will be learning what matter is made up of. And since your childhood you have learned that everything you come across in this world is made up of matter. It can be either an element or a compound or a mixture of elements and compounds. For example, the air we breathe, it contains elements like oxygen and nitrogen, and also compounds like carbon dioxide and water vapor. So in this lesson, we'll be learning in detail about elements, compounds and mixture. First, let's start with elements. Students, I want you all to turn your chemistry textbooks to page number 25 and mark down the key points as we learn. So what is element? An element is a substance that cannot be split. Split means divided. So an element is a substance that cannot be divided into simpler substances by a chemical means or by any chemical method or by any chemical reaction. So what is an element? Element is a substance and we cannot divide the substance anymore into simpler substances through through any chemical reaction or through any chemical change. For example, hydrogen, oxygen, nitrogen, carbon, magnesium, iron, aluminium, copper, silver and gold cannot be split into simpler substances by chemical means. So they are called as elements, and we have around 115 elements today. And elements are classified into metals and Non-metals. First, let's learn about the properties of metals. Metals have a luster called metallic luster. So luster means a shiny or attractive appearance. So metals have a shiny or attractive appearance or attractive look called as metallic luster. And second property is most of the metals are solids except mercury, which is the only metal that is liquid in normal conditions. So when you see in a mercury thermometer, so mercury which is present inside the thermometer is a liquid at normal conditions. Third, when struck they produce a sound. When you strike a metal, it produces a sound called as metallic sound or metallic clink. And fourth one, heat as well as current can pass through the metals. The common examples of metals are magnesium, aluminium, iron, tin, copper, gold and silver. Next, moving on to non-metals. Non-metals have the following characteristics. First, they are dull looking. Dull looking means they do not have a attractive or a shiny appearance, but they are dull looking except graphite and iodine, which are lustrous. Second, they are brittle in the solid state. Brittle means they break easily if we beat it or bend it. But the metals are not like that. It can be easily beaten or bent into sheets and drawn into wires. But non-metals are very brittle. They are easily breakable in nature. Next, they do not allow heat or electric current to pass through them except for graphite, which allows electricity to pass through it. And under normal conditions, most of the non-metals are in solid state and only bromine is in liquid state, and others like hydrogen, oxygen, nitrogen and argon are gases. And there are another set of non-metals like helium, neon, argon, krypton, xenon and radon. They are called as noble gases because they are inactive in nature. Next, we'll quickly go through the symbols of some common elements which is given in table 3.1. Elements are usually represented by their symbol. For example, aluminium is represented by the symbol Al. Argon is represented by the symbol Ar. Calcium Ca. Carbon C. And usually some elements are represented by one letter symbol, but some elements are represented by two letter symbol. And in some cases, the symbols are chosen from their Latin names. For example, lead. The Latin name of lead is plumbum and the symbol of lead is Pb. Next, iron. The Latin name of iron is ferrum. So the symbol is Fe. The symbols of some common elements are listed in table 3.1. I want you all to by heart this table, because you must know the symbols of the common elements which will be useful for you in your higher classes. Next, we are going to learn about compounds. A compound is a substance that can be split into simpler substances by chemical means. So compounds are substances that can be divided or splitted into simpler substances by chemical means. For example, water is a compound and it can be split into elements hydrogen and oxygen. Similarly, carbon dioxide can be split into element carbon and oxygen, whereas sugar can be split into or broken down into or divided into carbon, hydrogen and oxygen, and salt can be divided into sodium element and chlorine. Thus, carbon dioxide, sugar and salt are all compounds. So, from this we can understand that a compound is made up of elements. But if we simply mix the elements, we do not get the compound. So, compounds are formed when two or more elements combine chemically. For example, let's consider the formation of carbon dioxide and water from their elements. First, let's learn about carbon dioxide. Children, you all know that coal mainly contains carbon and air contains oxygen. But if you leave a heap of coal in the open air, does it form carbon dioxide? No, definitely not. But only if you burn the carbon, a chemical change, a chemical reaction happens and carbon dioxide is formed. So, carbon and oxygen chemically combine to form the compound carbon dioxide. Students, you can read the simple experiment given here, which proves that carbon and oxygen chemically combine to form the compound carbon dioxide. So next, let's move on to water. So if you just mix hydrogen and oxygen, will you get water? No. A mixture of hydrogen and oxygen does not form water unless kindled. So this can be proved by the following experiment. So first what you have to do is invert a dry jar containing oxygen over another jar containing hydrogen. After inverting, you just remove the lids and you wait for 10 minutes so that both the gases hydrogen and oxygen can mix thoroughly. After which, separate the jar and cover them. So now you will not see any droplets of water in either jar. So from this it's clear that just by mixing hydrogen and oxygen you won't get water. So what you have to do is now move the lid of one of the jar a little and kindle the gas mixture with a lighted matchstick. So what you're doing is you have to bring a lighted matchstick near one of the jar and you will hear a pop sound. So what you do is quickly close the jar and allow it to cool. You will soon see droplets of water on the inner walls of the jar. And the pop sound is because of the small explosion or blast that happened when hydrogen combined with oxygen to form water. So from this it is clear that hydrogen and oxygen chemically combine with each other to form water. So from this experiment we can prove that a mixture of hydrogen and oxygen does not form water unless we kindle it with a lighted matchstick. That is when a chemical reaction happens and water is formed. Next, let's confirm whether the properties of a compound differ from the properties of its elements. You can have a look at table 3.2 given in page number 28. So the properties of carbon, oxygen and carbon dioxide is given respectively. First, the color of carbon is black, whereas oxygen is a colorless gas and carbon dioxide is again colorless. Next, burns or supports burning. So carbon burns in air or carbon burns in the presence of oxygen, whereas oxygen does not burn but it supports burning. And third, carbon dioxide, it neither burn nor support burning. So from this it is clear that the properties of carbon and oxygen is completely different from the properties of carbon dioxide. And again you can look at figure 3.3. The compound lead iodide, which is yellow in color, it is formed by the combination of lead, which is silver in color, and iodine, which is violet in color. So we can prove that the properties of the compound are entirely different from that of its elements. We studied about elements and compounds. So now let's move on to atoms. So as you all know very well, an atom is the smallest part of an element and it takes part in the chemical reaction. So the atoms are the one that takes part in the chemical reaction and the atoms have the following characteristics. First, Atoms of an element, they are all alike. Alike means same. The atoms of an element are all same. That is, they have the same properties. Second is the atoms of an element are different from those of other elements. For example, atoms of hydrogen will be different from the atoms of oxygen or from the atoms of carbon. So, atoms of an element are different from those of others. Third, atoms of an element show all the properties of the element. For example, every atom of hydrogen will show the properties of hydrogen, and every atom of oxygen will show the properties of oxygen. Next, let's see how atoms are represented. An atom of an element is represented by the symbol of the element. For example, H represents the atom of hydrogen, and C represents the atom of carbon, and N represents the atom of nitrogen. We studied about atoms. Now we'll move on to molecule. What is a molecule? A molecule is the smallest part of an element or a compound that can exist independently. So atom cannot exist independently, but it takes part in a chemical reaction. But a molecule is the smallest part of an element or a compound that can exist independently. So you can watch in figure 3.5. Atoms of hydrogen, carbon, nitrogen and oxygen is given. Next, molecules of elements as well as molecules of compounds are given. So first let's see what is meant by molecule of a element. The atoms of same element combine with each other to form the molecule of an element. For example, an atom of hydrogen combined with another atom of hydrogen to form a molecule of the element hydrogen. And similarly, an atom of nitrogen combined with another atom of nitrogen to form a molecule of element nitrogen. Whereas the atoms of different elements combine together to form the molecule of a compound. For example, the atom of element hydrogen combined with atoms of element oxygen to form molecule of compound water. Similarly, atoms of element carbon combined with two atoms of element oxygen to form the molecule of compound carbon dioxide. Next, let's move on to pure substances and mixtures. So what are pure substances? A pure substance is one that cannot be split into simpler substance by a physical means such as filtration, sublimation and distillation. Whereas mixture is a substance that can be separated into two or more pure substances by a physical means such as filtration, sublimation or distillation. So from this definition we can understand that pure substances are substances that cannot be split into simpler substances by physical means, whereas mixtures can be separated into two or more pure substances by a physical means. The common examples of pure substances are elements like carbon, nitrogen, oxygen and compounds like carbon dioxide, water, glucose, sodium chloride. So all elements and compounds are pure substances. Whereas a mixture is made up of many pure substances combined with each other, and the pure substance that make up a mixture, they are called as components of the mixture. So children, I'm sure you all would have eaten the snacks, mixture snacks, isn't it? So it will be made up of many different variety of grams and dal and nuts. So these are called the components of the mixture. Gram, dal, nuts, they are called the components of the mixture. Pure substances they do not exist independently in nature. They usually mix to form the mixtures. For example, air. Air is a mixture of gases like oxygen, nitrogen, carbon dioxide, and water vapor. Even the ordinary water we drink is a mixture of calcium, magnesium salts, and even some air is dissolved in that water. So water is also a mixture of many number of salts, and soil, rock, minerals, all of these are mixtures of variety of substances. Even the food we eat is also a mixture. Okay, it is a mixture of substances like carbohydrate, proteins, vitamins, salts, etc. And these mixtures can be artificial also, artificial or man-made. And the mixture of metals are called as alloys, and they are usually stronger than the pure metals. Alloys are usually formed by fusing or combining the metals with other metals or with non-metals, which is followed by the process of cooling. So for making jewelry, gold is mixed with copper and silver. It is alloyed with copper and silver. And steel is an alloy of iron, carbon and manganese. Even cement is made from a mixture of compounds like calcium and aluminium. So various medicines, pesticides, they are all also mixtures. Lastly, we'll quickly go through the characteristics of a mixture. First, the components of a mixture may be present in it in any proportion. For example, when you take a sugar solution, you can either add 1 spoon of sugar in water, or you can add 2 spoon or 3 spoons. So the component of mixture may be present or may be added in any proportion, any amount. Proportion means amount. Next, the components of a mixture coexist without chemically reacting with one another. For example, when you take a salt water mixture, the salt and water doesn't chemically react with each other. A chemical reaction does not take place here. So the component of the mixture coexist with each other without chemically reacting with one another. And third one, the components of a mixture retain their property. For example, a sugar solution will be sweet and watery, whereas salt solution will be salty and watery. So the components of the mixture, even though you add sugar to sugar solution, the property of sugar, the sweetness of sugar doesn't change there. So the components of a mixture will retain, will continue to have the properties. Fourth one, the components of a mixture can be separated by physical means. So through physical process like filtration or distillation or sublimation, we can separate the components of the mixture. For example, soil and water can be separated by the process of filtration, and sugar or salt from water can be separated by the process of distillation. So you'll be learning about the process of separating the components of mixture. You'll be learning it next. So just remember that components of mixture can be separated by physical means like filtration or distillation or sublimation or magnetic separation. So my dear students, in this video we have studied about elements and compounds, atoms and molecules, pure substances and mixtures. And now it's time for you to complete your classwork notes. Write neatly and legibly in your classwork, children, and also complete your book exercise. Thank you for watching this video. Have a nice day.